Hello and welcome once again to Quest, which is the weekly inter-school science quiz, which is brought to you by the National Council of Science Museums and 𝐿 Kendra, Kolkata. Two new schools, but first let me introduce the quiz master today, Mr. Anil Manikar, who is the director of the National Science Centre, New Delhi. Hello, sir.
Thank you.
So are you enjoying Calcutta so far, sir?
Yeah, it's a beautiful city.
Introducing the teams to you today, the JC Bose team are the girls from Julien Day School, and you are?
Hi, I am Mohana Roy from class 11.
And?
Hello, I am Hoimonti Mitro. I am from class 11.
Hello, I am Shohini Basu from class 11.
Have you seen a show ever on the television?
Yes, sir.
Well, I guess you know the format more or less. And the team on my left are Techno Model School. We had three other faces from your school last week, and you are?
I am Niladri from class 12.
I am Shivarti Das from class 12.
I am Shilaita Majumdar from class 12.
And have you also been watching our show?
Yes.
Well, let me explain the rounds as we go along. The first four questions are direct questions. The last three are on the buzzer. More about the buzzer when we get to them. The direct questions carry 20 points. That is, for the direct question asked to any particular team, if you answer within 15 seconds, you pick up 20 points, at the end of which it will pass, assuming you've not answered, to your opposite team, the rival team, who can then pick up 10 points for it. Unanswered questions go into the audience. JC Bose team, are you ready for your first question? Yes. Well, Mr. Manika, over to you.
Okay. You are all familiar with this? What is this one?
Fan.
Simple ordinary fan. Okay, I removed the front grill because I am going to perform a simple experiment on this. And you can see there are 4 blades, right? And they are marked 1, 2, 3 and 4. I have another device which is simply nothing but a flashing light. Okay, you can see that. You can see the light is flashing?
Yes.
Right? Okay. Now my job is, I will be directing this flashing light on this revolving fan blade.
Which way to both teams?
Yeah. And now I will be changing the knob here just to see what happens to the fan blades. What do you see here? Are you able to see anything? Now it is almost stationary, isn't it?
Yes, sir.
And now it is rotating in a clockwise direction. Okay. Question is, I said that fan is rotating fast. I said that there is a flashing light. Now when I project this flashing light on the blade, why do we see sometimes the blades are stationary? And then you can further tell me why sometimes clockwise, sometimes anti-clockwise. At least you should tell me why do you feel that blades are stationary.
So due to refraction of light?
You would like to add something, you go on.
So the direction of the blades are changing due to the refraction of light?
Anybody wants to say anything?
Light waves are bending.
Bending due to the movement of air.
Okay, I think I should try this with the other team. You have anything?
CV Raman team, can you throw more light on the matter than Mr. Manikar already has?
Sir, I can only just persist the view image only for 1.8 seconds or something.
After just one image after that, only after just 1/8 of a second. Now when we project this light, the intensity it is reflecting, and now that just
okay, we are seeing it because the light is reflecting from that is fine.
because
But
of the
why?
intensity of the light, we are changing it now, and the speed of the fan as it's the same, and this is changing. So
So there is an optical illusion over there.
You are right. You are going in the right direction.
Sir,
Tell
there
me.
is an optical illusion because of the speed of, because how I can persist only image for 1.8 seconds changing. Sir, so this is the main reason for the optical illusion, which is creating this type of image in front of us. I mean this type of phenomenon.
You want to say anything, or I should
I
pass
think
on to
we
the
should
audience?
go into the audience.
I
Yes,
think
anyone
so.
in the audience?
Yeah. I think I had given enough clue when I was speaking.
The answer is fairly simple. I guess Mr. Manikar, you best explain.
Okay.
You can, yeah.
Yeah. I said that fan is revolving fast and this is a flashing light. Okay. And when we are directing a flashing light towards the fan and I am changing something here, I am changing the speed of flashing of this light. Okay. What will happen when the fan blades are revolving at say 1200 revolutions per minute and flashes also are exactly same 1200 flashes per minute. I will see the blades stationary. The blades are marked 1, 2, 3 and 4. When the blade 1 is on the top and the light flashes, it makes one cycle, again it flashes, makes again one cycle, again it flashes. So, every time when it matches, I will see it stationary. Okay. And if the frequencies are little bit mismatched, if the speed is slightly less or more, the speed of the fan and the frequency of the flash, if they are slightly differing, then you will see them slowly revolving in a clockwise direction or the anti-clockwise direction. So, that is the basic principle here. It is called stroboscope.
Very nice question then. Thank you. Well done. Nice explanation there, Mr. Manikar. No team picking up any points. The next question will be for the C.V. Raman team.
Okay, I have another setup here with lot of wires and some device called a transformer. Okay, and this is a special transformer here I have which can generate a very high voltage of the order of 12,000 volts. I have two metallic rods, you know metals are electrically conductive, and the transformer is connected to this one, and I am going to give power to this device. Let us see what happens. Are you able to see a spark between these two rods? And the spark generates at the bottom, okay, and then it is moving up, and then it breaks, and then again it starts at the bottom. Are you able to see that? Okay. Now the question is, why there is a spark and why does it travel up?
So, well sir, for the transformer the voltage is stepped up.
Yes.
And it is very high, and so as the both rods are of a high voltage, so therefore there is a they tend to just go towards the edge or conduct the electricity.
Okay.
Now as the distance between them and the bottom is less, minimum, so there we see the charge just originating. As it go up and we see that the distance is increasing, and hence it disappears as we go up.
This exactly what is the reason. I think I wish you add a little bit in that. Your answer is right. I am going to give you full points.
They are in
Okay.
they are in contact.
Okay.
Niladri, is there something you can add to this?
Well, I am trying.
They are in contact, and so
They are
the
not,
light is
in
generating.
contact. So
They are not in contact.
Not in contact. The air is not is also non-conducting, and hence as a mechanism of the lighting of clouds we can apply to this.
No. What is happening here? There is a very high potential. Okay. Anybody? You want to add? Of course, the answer
Yes.
they are getting right. You can say that.
Why don't you come up here? Come here. Hold the mic. What's your name?
I'm Devraj Lady from Haryana Vidya Mandir.
Debraj, were you not on one of our shows
Yeah,
previously? You were. Well, welcome back.
Thank you.
Yes, tell us.
Well, the two rods are connected to two different potentials of the one. So they are two different, I mean one is positive, another negative. So it's very high voltage, so the current that will tend to flow from one to other will be also very high. But since the air is it's a bad conductor of electricity. So when we try to move, the current will try to move from one rod to another, resistance will be offered, and that will cause heating of the air.
That's
That
right.
produces the spark.
Okay. Okay. He came very close to the answer. I would just like to add few things in that.
Do we give him a memento? What do you say?
Definitely, he deserves that.
He deserves a big hand too in that case. Well, Devraj, here's something for you which you can show your family and friends at home to tell them that you were here. Yes, Mr. Manikar?
The thing is, as I said, there is a very high potential transformer here. The two rods are there, they are not touching with each other, and this high potential is applied across these two rods. Now what happens? The electricity will try to flow, but there is a air in between them, and air is not a good conductor. But the potential is so high, it breaks down the resistance of air. Now where it will find the minimum resistance path? Naturally at the bottom place where there is a less amount of air. So the spark develops there because of the high voltage and the minimum resistance path. What happens when the spark is already developed, the air which is above the spark, it gets heated, and this air gets ionized, and you know ionized air is a good conductor. So there will be a minimum resistance path above the spark.
All right.
The spark will move up, and further the process will continue. The air above the spark will get heated, get ionized, the spark will move up and move up and move up, it will go up. But the distance between the rods is increasing. So it becomes difficult for this potential to hold that charge. So it breaks there. The moment it breaks here, again it tries to find out where is the path for the minimum resistance, and again that is at the bottom. So again the spark develops at the bottom, again it rises, breaks, and it continues. So that is a good answer.
Okay. Well done, C.V. Raman team, you picked up 20 good points there. The next question is a direct question, and that's for the JC Bose team. Well, Newton's third law says that every action has an equal and opposite reaction. JC Bose team, whenever you asked a question, we find no answers from you. I hope that's not the reaction in your case. No? Well, we hope the next question spurs the right response from you. Mr. Manikar.
Yeah, I think this is a fairly simple thing which you might have done in your home. Everybody has possibly touched the ice cubes. I have a few ice cubes here and I will take them out. And I will take another one. Okay, so I have two ice cubes here. I will hold them together. Okay, and I will press them against each other, and probably you know what is going to happen now. Okay, I press them, I release them. You see what is happening?
Magnetic ice cubes.
There is a hidden magnet or no? No, there is no magnet in this. So the question is simple, why did they join? What is the science in this experiment?
So this is due to regulation.
Regulation, the pressure is increased.
The pressure is increased, so the melting point decreases.
Okay, okay.
So the ice cubes join together
and form join together
to one single piece.
to one single piece.
Yes, yeah, you gave the answer right, it's right. So let's give them a big clap. When the ice cubes are pressed against each other, what happens? There is the pressure, and the ice at this junction melts. Okay, it melts into the water. But when I release the pressure, it expands, and due to that expansion, it cools further, and then it freezes. So that's how it joins.
Well done, JC Bose team. You pick up 20 points there. Scores now tied, even Steven, 20 points a piece. Next question is for the C.V. Raman team. Welcome back with 20 points apiece, both teams tied at the same score. Next question for the C.V. Raman team. Mr. Manikar.
Okay, here is a simple setup, arch like thing holding two balls which are suspended by a thread, and the balls are having some gap between them. You can see that?
Yeah.
Okay. And now I am going to blow in between these two. Okay. Let us see what happens. What did you see?
One is moving fast, one is.
No, when I blew air in between them, did they go away or they collided with each other? You can see it again. They collided with each other, that means they came close, right, but it is exactly opposite what we expect. When we blow air, they are supposed to go away, but they are behaving in a different way. They are instead coming closer. Of course, then later on they get dispersed. So, initially they are colliding with each other, they are coming close to each other. So, the question is, why do they come close? It is a simple question.
Hurry up, must start. Yes.
Sir, when we blow the air, as the gap is small,
Yeah.
when we blow the air, because of the spherical shape, the air just gets, the bulk of the air, they get displaced on the both sides, and hence from this side a pressure is applied, the force is applied on the balls, and hence they collide with each other.
What is this principle? Okay, I will decide whether to consider this as right or
Girls?
not. I will give them a chance.
The surface in which the balls are kept, when we blow air to that area, the amount of air increases,
Okay.
and so the balls come in contact with each other.
Amount of air increases, so why should they come in contact with each other?
So the sir, it is
There in the other sides there are
forcing the balls to collide.
Air pressure.
The air pressure
surrounding the balls.
balls increases.
Okay, since you said one step higher than what they have said, I will give them a correct point again.
Okay, 10 points. Let's have big
10 points for them.
Big applause for them.
Okay. I will just add up to what you both have said.
Yes, Mr.
When I am blowing air in between them, okay, the air has to travel at a higher velocity because the gap is narrow here. Okay. So, when air travels at a higher velocity, what happens? Pressure decreases. The moment pressure decreases, they will collide with it. And you said that pressure something. Okay. Though you also were on the right track, but you could have added little more in that. So, this is what principle? Exactly. This is Bernoulli's principle.
Well, a change in the scores then. The girls from the JC Bose team pick up 10 points. They now move on to 30 points. CV Raman team still remain where they were. That's 20 points. Welcome back. You're watching Quest. The fifth question today is on the buzzer, and as always, plus 20 if you get it right and minus 10 if you do not get it right after hitting the buzzer. These questions will not pass over to the other team, they'll pass straight to the audience. Mr. Manika, are you ready?
Yeah.
All right.
Okay, let's take a beaker full of water, and I have a, what is this shape called as? Oval shape. So you know what it is. Yeah. So what you know what it is? It's an egg. Okay. Only thing I don't know why it's black.
Well, I guess Shubharti, did you go for the buzzer?
Yes, I.
You did. Shiladitya, why don't you give us an answer? What are we going to ask you?
If the egg is put on the water,
Immersed into the water.
immersed in the water, into
Yes.
the water,
Yes.
it will
There will be a total internal
total reflection, and it will be silver, look silver in color. It is black in color, and there are air gaps, air bubbles in the surface of the egg. So there is a total internal reflection of the light, and it will look brighter. It will look silver in color.
Silver in color from the outer surface.
Have you finished?
Yes.
Mr. Manikar, would you like to ask the question now?
He has stolen my tongue rather.
Yes. Okay. So why don't you ask us the question now?
Anyway, the question was same. When I put it in water, why do I see it silvery? The egg becomes silver egg. Okay. The question was same. Let's see, but let's see whether it really happens or not. Are you able to see that? I think maybe you have to come closer. And then
Is it the same egg, Mr. Manikar?
it's the same egg. Okay. Let us give them a big clap. They have given a correct answer.
Good answer there, Shiladitya. Mr. Manika, we've all heard about that goose which laid the golden egg.
Yes.
You seem to have created a silver egg from
Silver.
nowhere.
But I'm not goose.
Can you add to his answer in any manner?
Yeah, the thing is same. When the egg is basically white in color, it has been held on the candle flame to make it black. So it's a black soot all around the egg.
It's carbon coated.
Carbon coated. Now what happens in this process? Lot of air molecules get trapped, and when you place it in water, because of these air molecules all around the body of the egg, you see silver color because of the total internal reflection of the light. The light which is falling on that, it gets completely reflected back. So we feel it's silverish. That's the correct answer.
40 points to the C.V. Raman team and 30 to J.C. Bose. Second last question again on the buzzer. Mr. Manikar.
I have a simple toy again. Okay. Here is a pipe and I have a piston which can move in and out. Okay. I can take it out even. Now I am going to blow some air on the top of this. Okay. Let us see what happens. You hear a change in the note? The frequency of the sound is changing. Now, why the frequency is changing?
Girls.
Because the length of air column inside the tube is changing, that's why the frequency of the sound is also changing.
What do you want to say?
Sir, because of the nodes and antinodes.
Of course, the question is not passed on.
It does not pass. Let's
Yeah.
yes,
The
Niladri.
nodes and antinodes, we have a closed tube here. So for that we have the graph like thing. So for that the nodes and antinodes we get the different pitch of sound.
Yeah, but since they have pressed the buzzer first and they also have given the correct answer, they get a point for that. And the answer is simple. When I am changing the length of the air column, okay, the frequency is bound to change because of the change in the length of the air column which is vibrating. The nodes and antinodes are definitely there. Okay, so bonus point are the points for them.
With that, I guess we'll move on to the very next question with the scores reading 50 now. That's to the J.C. Bose team, and the boys from C.V. Raman team remain on 40. Welcome back. You're watching Quest, and now the very last question. Anything can happen. We've had a change in score almost every question which has been asked over the last 3-4 rounds. Mr. Manika?
Yeah, I think we have been playing few toys today. Let's play another toy, and I'm sure you all might have played with this simple toy. You had, right? Okay. Let's see how we play with this. There is one which is yellow colored ball, other one blue. Okay. So when I am hitting it, one stops, one goes up, it comes back, it stops, it goes up, it continues. Now the question is, what is the science in this?
Ten seconds. Yes, Niladri.
Is this the effect of force vibration? Now, sir, when we hit, so it is rotating. The first ball is rotating, and now it.
I think I will have to pass on this question to the audience.
When the you are applying a force in the handle, and the topmost lowermost ball is getting a force which is greater than going to a vertical circle, and when it is coming down, the energy is transmitted to the blue ball, and it will again go up.
Yeah, but I think you said something which is grossly wrong. So let me see if audience
in the audience.
Yeah.
Yes. Why don't you come up? Yes, you come. Yes, come and hold the mic.
You want to play with
What's
this?
your name?
I'm Hafsha Rahman from Haryana Vidya Mandir.
Excuse me.
Hafsha Rahman.
Yes.
So this is a case of elastic collision. Both of them have the same mass. So like one is striking, so the other just going because the velocity is getting interchanged between them.
Okay, it's a case of elastic collision, that's true. What happened, this is called a Newton's cradle. The ball which is moving in this circular direction, it comes here, when it hits this one, it passes its momentum to this ball. Okay. Momentum is what? Nothing but the mass into the velocity. So when it passes this momentum to this one, it comes to standstill, this gets momentum and it moves around, and then it comes with the momentum now, it passes its momentum to the one and it comes down. So I think we should give marks to nobody.
I think we should give a big round of applause to Absha. Well done. Good memento for you. Well, choosing to keep quiet and not going for the buzzer, the girls remain exactly where they were, that's 50 points, and in the process winning today's contest. Well done, girls. Your final score tally, 50 points. Thank you for being on our show, Sohini, Hoymanti and Mohana. Boys, I guess you really had no option but to go for that buzzer there. Good strategy, didn't pay off. 30 points is your last score. That's Niladri, Shubharti and Sheeladitya. Thank you for being on our show. We hope you've enjoyed watching our show. Please do write in with your comments. Our address, very much the same as before. Quest, care of Doordarshan Kendra, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. We'll see you again next week with 2 new schools. Till then, it's goodbye from all of us.